six molecular relation.
So I'll try to do it in English, and good afternoon. Thank you very much for the opportunity to present my work. You might have some deja vu, as several of my slides were shown by my advisor, Professor Cohen, before. So the sirtuins are a conserved protein family that function as the regulates. In mammals, you can find 7 sirtuins designated SIRT1 to 7. They differ in their cellular organization, and the protein deregulates. SIRT6 is a nuclear protein that functions not only as death-regulated, but also as ADP, resistance therapy. Mice lacking SIRT6 have many abnormalities and they live 1 month at most, whereas mice overexpressing SIRT6 live longer, about 15% in compared to wild-type mice. This work of mice overexpressing SIRT6 was conducted by Dr. Yariv Kafin from our lab. A proper disclosure, if I would have given this lecture 1 month ago, I would have claimed that SIRT6 is the only mammalian sirtuin that was found in the same lifespan in mice. But in the last month, it was an article in Cell Metabolism was published, and it was shown that mice that overexpress SIRT1 in specific areas in the brain also show a phenotype of extended lifespan. So when we try to decipher the molecular mechanism that confers mice overexpressing SIRT6 and improve the lipid profile and confers them resistance to metabolic disorders, we focused on sterol-responsive elements by protein 1 and 2. I will call them SRAB1 and 2. We focus them because they are master regulators of lipid and cholesterol and fatty acid synthesis and uptake. They reside in the ER as precursor. They are as inactivated precursor. With the appropriate signal, they are being cleaved, and a portion of this protein enters the nucleus, and then they become transcription factor that binds the responsive element DNA sequence, and thus they transcribe gene related to cholesterol and fatty acid synthesis. So when we try to, so you can see that with overexpression of SIRT6, you can see that many of these genes related to cholesterol and triglyceride biosynthesis is downregulated with overexpression of SIRT6. When we perform 14AP experiment, we saw that SIRT6 is enriched in the promoter of SRABP1 and 2 and in several of the target genes. We also saw that upon SIRT6 overexpression, you can see that HLHK56 is one of SIRT6 target. Is also SIRT6 close to the acetylation of HLHK56, and this way it keeps the balance towards etochromatin state that downregulates, that leads to downregulation of these genes. When we look at the protein level, you can see that under overexpression of SIRT6, you can find most of SRABP1 and 2 as the inactivated precursor and much less as the active nuclear form. You can see also that SRABP1 is being phosphorylated as SRE372, and this was found to show that this was found as inactivated phosphorylation. The kinase that phosphorylates SRABP1, and I will talk is AMPK. I will talk in a minute. So you can see that AMPK is overexpressed, is a little bit overexpressed in SIRT6 under SIRT6 overexpression, and is also activated activated means that it's being phosphorylated. So AMPK is known to be an ultrasensitive kinase. It is ubiquitous kinase, serotonin kinase in the cell, and it's known that as ultrasensitive sensor to the fuel energetic state in the cell. It's usually being activated when the ratio AMP to ATP raises. So we check the level of the nucleotides in the cell, and you can see that upon overexpression of SIRT6, the ratio AMP to ATP is twofold higher. So it means that this way SIRT6 can activate AMPK. We also conducted an experiment where we overexpressed SIRT6, but together with knockdown of AMPK. And you can see that this bar, the black bar, is the control. This light gray bar is what you saw before, what happened under overexpression of SIRT6. But you can see that when we combine overexpression of SIRT6 together with knockdown of AMPK, it's actually restored the expression level of the gene, meaning that the effect of SIRT6 is mediated at least partially by AMPK. Okay, so we know that SREBP1-2 is being cleaved by a protein complex constituted of 3 proteins, SCAP, S1P, and S2P. And we found what happened and we looked for what happened under overexpression of SIRT6. And you can see that in this under overexpression of SIRT6, these proteins are being downregulated. We also look what happened in the promoter region, and you can again you can see that SIRT6 was found to be enriched in the promoter region. So the overall result is that you can see that these proteins are being downregulated, and thus you have less proteins that cleave the SREBP1 and 2 to their active form. Another interesting point is MIR33 that was found to regulate SIRT6, to downregulate SIRT6. And basically we found there was some regulation. So MIR33 was found to downregulate SIRT6 and MIR33 has 2 isoforms, MIR33A and B. They are both located in bonds of SREBP1 and 2. So MIR33 is co-described with SREBP1 and 2. And this is basically the way that SIRT6 and SREBP1 and 2 do opposite things. So when SREBP1 and 2 are active, they want to make sure that SIRT6 will be downregulated, and they do it via MIR33. So we also found that under overexpression of SIRT6, you can see that the level of MIR33A and B are downregulated. So we came up with the following model. SIRT6 is being downregulated by MIR33, which is located in the intron of SREBP1 and 2. SIRT6 in its turn downregulates the transcription level of SREBP1 and 2, and also the protein complex that cleaved in. SIRT6 also activates AMPK by raising the ratio AMP to ATP. It's also LKB, it's one of ATP kinases, and we found that SIRT6 also upregulates LKB. So SIRT6, by raising the ratio AMP to ATP, brings to upregulation and activation of AMPK, which in its turn phosphorylated SREBP1, and causing it to be preventing from going its cleavage and entrance to the nucleus. Okay, so thank you very much for Chaim and the rest of the lab.
So if you inhibit MIR33, can you increase the levels of SIR6 to the levels that are comparable to the levels of SIR6 when you overexpress it in the mice? And these are levels that cause the increase in longevity.
in tissue culture, when you downregulate MIR33, you can see that the level of SIR6 are raising. What happened in mice? We haven't done it. But when you overexpress SIR6, it will be higher level than, MIRs in general are very delicate, and it's very delicate, and it's in lower level than you actually overexpress a protein. But it could, but of course it influences the level of SIR6.
תודה רבה, יש לנו עכשיו 40 דקות עד הפאנל הבא, יש את הסנדוויצ'ים, מי שרוצה לקפוץ לקחת כמה בתי קפה, יש פה...
זה 2 דקות.
שאול המלך?
שרת.
זה קשור גם לסוג של... משפחה גדולה
ב-8:32 או
ב-7:10? רציתי להגיד הרבה פעמים מנסים למצוא קורלציה בין מיקרו-RNA כאלו ואחרים. או עם אייג'י.
זה לנסוע מפה, זה לוקח... בעיקרון לנסוע מפה לוקח 7 דקות לשם. השאלה היא איך לתפוס מונית פה. כאילו לחברושים.